My name is Dennis, and I am the product manager for Golden Gate for Big Data. And today, for the next roughly for 20 minutes, we are going to run the session together for the updates about Golden Gate for Big Data. And also, I will mention some couple of use cases from our customers. So, with more than 30 different technologies supported, Golden Gate for Big Data supports many different use cases. And one of the most common use cases that we see among Golden Gate for Big Data customers is streaming ingest into Kafka. And you saw that like our customer from Czech Republic, they're also using Kafka. And as Jeff mentioned, more and more customers, they're looking into ACID capabilities for big data technologies. And it's the same for Kafka. But we know that, especially for Kafka, it is not ACID by itself. So what we do with the Golden Gate for Big Data is we extend the ACID nature of change data transactions into streaming platforms by enriching the messages with source metadata, by tracking schema drifts, and also by performing rollback operations with Golden Gate. For example, we have a customer from online payments industry, and they're using Golden Gate to trigger payment confirmation messages. So what happens is, once the payment transaction commit is completed in the core system, Golden Gate captures the transaction and sends a message to Kafka, which triggers a payment complete message sent through the payment application UI to the end user. Another common use case that we see among our customers is a data lake or data lakehouse streaming ingest. So we see that more and more customers are looking into streaming messages or streaming data into their data lakehouse in real time for enhancing their analytics and for enhancing their machine learning algorithms. And data lakes may consist of various data storage and formatting technologies like OCI object storage, Azure Synapse, Google Cloud Storage, like from formats like JSON, Avro, or Parquet, like different formats. And Golden Gate for Big Data supports most of these technologies with improved replication and performance capabilities. And another more recent use case that Golden Gate for Big Data supports is actually the data capture from big data technologies. So currently, you can use Golden Gate for Big Data to capture messages from Kafka, from MongoDB, from Cassandra, and from data stacks. And they also have their own use cases. So for example, we have customers using Golden Gate for Big Data, migrating from MongoDB into autonomous JSON database in a no downtime architecture. We also have like a couple of other customers who are migrating from Cassandra database into MongoDB with Golden Gate for Big Data. So these kind of big data migration use cases are supported by Golden Gate for Big Data itself. And one last common use case that I want to mention is stream data processing. So Golden Gate Stream Analytics is bundled with Golden Gate for Big Data. And once you purchase or once you buy Golden Gate for Big Data, you also obtain the right to use Golden Gate Stream Analytics together with it. So you can use Golden Gate Stream Analytics to apply business logics to the data in motion to create value out of your data. Today, Golden Gate for Big Data supports 30+ different technologies as source and target. And I think it's not wrong to say that Golden Gate for Big Data is one of the most heterogeneous solutions that we have in Oracle today. And when it is combined with the various data formatting options in Golden Gate for Big Data, like JSON, our OCF, Parquet, delimited text, and others, it enables our customers to create replications in hundreds of different variations. And also, with technology and use case specific properties, you can customize your replications to meet your business requirements. This set of properties that I was mentioning, they would help you to control every step of the replication process. So for example, you can apply file format specific conditions while ingesting files into cloud storage services. Or you can dynamically assign message keys while streaming into Kafka platforms. Or you can control the pace of the merge operations for stage and merge targets. And many more different properties that are supported by Golden Gate for Big Data. And on top of these transactional replication capabilities, with Golden Gate for Big Data, you can also use Golden Gate Stream Analytics, as I mentioned. And we see that we have customers mostly using Golden Gate Stream Analytics for real-time ETL processes or for real-time event management. We have a customer from APAC region, and they're a bank, and they're actually using Golden Gate for big data, and Golden Gate Stream Analytics all together for managing their real-time event management platform, which actually triggers real-time outbound campaigns for their banking customers. So as already mentioned by Julian and by Alex, Golden Gate comes with different deployment options, and these deployment options, they are valid for Golden Gate for big data as well. So you can either run Golden Gate for big data in your own data center, or you can install it on a third-party cloud, or you can use it as a fully Oracle managed cloud native service on Oracle Cloud Infrastructure. OCI Golden Gate for big data comes with its own unique advantages. And the biggest advantages, OCI Golden Gate is licensed based on the data throughput, and it is more cost efficient to run. It also benefits from unique OCI capabilities like auto-scaling, integration with OCI monitoring services, and many other. And it is much easier to configure your applications with OCI Golden Gate. And also, we are providing third-party libraries as pre-configured in OCI Golden Gate for big data targets. And also, most of the replication properties are pre-configured and automated as well. So earlier today, during our session, there was a question about improvements with the Golden Gate for big data properties. And I know that sometimes in Golden Gate for big data replicates, we have a very long list of properties that users need to modify. But especially with OCI Golden Gate, we are enhancing it and we are making it more easily. So actually, like after my session, Julian is going to demonstrate Snowflake replication with OCI Golden Gate, and you're just going to see how it is easier to configure replication with OCI Golden Gate big data deployments. So as of today, OCI Golden Gate big data supports 6 different technologies as source and 16 technologies as target to deliver the most of the highly demanded use cases like real-time ingestion to cloud data lakes, data streaming, and from like different Kafka platforms. And it also supports cloud native data warehouse integrations and also migrations from document databases. So by the way, I just said as of today, but some of these customers are going to be available very soon, in a day or so. And even though OCI Golden Gate for big data was launched a few months ago, we have many different customers adopting these different use cases and these different connection technologies. And I'd like to just like share a couple of them with you and what they're doing with OCI Golden Gate for big data. So we are working with one of the customers from the APAC region, and they are using OCI Golden Gate for ingesting Parquet files into Azure Data Lake storage for real-time analytics and for machine learning. They're running end-to-end replication within a private network. So they have their source database running on OCI with a private subnet, and they also operate their OCI Golden Gate deployment in a private subnet as well. And they have an interconnect between their OCI and Azure services. And they are replicating into Azure Data Lake storage account with a private endpoint. By the way, they're still in the development phase, but when completed, we are expecting that they will be replicating from, hundreds of different tables and databases into Azure Data Lake storage with OCI Golden Gate. And another interesting use case is with another customer from North America. And this customer is actually from a fitness application industry. So this customer is using OCI Golden Gate to stream data from their Exadata Cloud service into Amazon MSK. And the more interesting part of their use case is they also capture from Amazon MSK with OCI Golden Gate, and they replicate it back to Exadata Cloud service. So their application consumes the messages from MSK, but also it produces new messages that are sent back to Exadata Cloud service by OCI Golden Gate. And they do it for some analytics reasons or analytics use cases, as far as we know. Another use case that I would like to mention about is from Latin America. So right now, actually today we are going all around the world. So this customer from Latin America has tested OCI Golden Gate for big data, and they tested streaming into OCI streaming. And by the way, if you're not familiar, OCI streaming is an Apache Kafka compatible event streaming platform fully managed by Oracle. So before that, before this testing, customer was running on-prem Golden Gate for big data, and they were replicating 3,500 messages of 400 bytes each per second into a single topic. And they were using classic replicat. And just to improve the performance, they were running several different replicats targeting the same topic. So they were trying to create some additional throughput. So the Oracle A team from Latin America, they used OCI Golden Gate for big data, and they were targeting a single topic in OCI streaming, and they wanted to test the same scenario. So they configured a single coordinated replicat targeting the Oracle streaming topic. And then we noticed that the replicat published 25,000 messages of 400 bytes per second. And that was a big difference when you compare it with customers' 3,500 message per second requirement. And of course, like there will be different factors in the performance, like network latency, network performance, or the size of the data, and other variables. But when you just compare it, it's actually a big difference. And like more, we have a very detailed blog post about this test. And if you're interested in it, and if you just want to see the details about this test and how the replica is configured, I just left the link in the slide. And when you receive the deck, you can just click on it and you can review the detailed blog about the performance testing. Okay, so now a couple of news about Golden Gate for big data. One of the most common feedbacks we received over the years about Golden Gate for big data was about its cost. So back in October 2022, we released a new licensing model for on-prem Golden Gate for big data, and we called it Golden Gate for big data targets. Golden Gate for big data targets offers a new pricing model where customers have an option to purchase targets individually. So for example, let's assume that you want to replicate to only Confluent Cloud with Golden Gate for big data, and you're not interested in replicating into other target technologies supported by Golden Gate for big data. So in that case, you can use Golden Gate for big data targets SKU, and you can replicate into that single Confluent Kafka target with Golden Gate for big data targets. When compared with full licensed Golden Gate for big data, the biggest difference is in the number of target technologies that you can replicate to. With Golden Gate for big data targets, as I mentioned, it is limited to a single target technology. But the important point is, it is the number of target technology. So let's assume that you want to replicate into Azure Data Lake Storage in JSON format, in delimited text format, and in Parquet format as well. So still, we count it as a single target technology. So it doesn't kind of like limit you from technical perspective or from a functional perspective. And actually, once you opt in for Golden Gate for big data targets SKU, you still use the same Golden Gate for big data binary. So what you do is you only commit to use the software with a single target technology. Golden Gate for big data targets is a great fit for budget cautious projects with a single big data target. You can get more details about Golden Gate for big data targets, again, from the link that I left in this slide. So we have all the pricing details in this blog post. And if you're interested, you can check that blog post for more details. So apart from the licensing changes, or let's say new licensing options, we also did improvements on the technical side. And from the technical perspective, we released a couple of new sources and targets. And we also improved the initial load performance, especially for data warehouse targets. So from the connections perspective, we introduced Redis as a target technology with Golden Gate for Big Data, with Golden Gate for Big Data 21.8. And we also added Apache Cassandra version 4 and data stacks as source technologies into Golden Gate for Big Data. And as I mentioned, like the most significant improvement is in the initial load performance with Golden Gate for Big Data. We introduced a new parameter called insert all records, and it is used in the initial load processes. So this property directs the replicate process to use bulk insert operations for the initial load. And today, insert all records is available for Snowflake, GCP BigQuery, Azure Synapse, and AWS Redshift. So if you're just like curious about how much improvement we get with these performance improvements with Golden Gate for Big Data and insert all records parameter, I can give you an example. So I was working with a customer a few months back, and they were testing replicating into Snowflake. So they were running both initial load replication as well as CDC replication. And first, in the beginning, they were using Golden Gate for Big Data 21.4. And they had a table which was sized like nearly 74, 75 gigabytes. And with Golden Gate for Big Data 21.4, it took them around 6 to 7 hours, unfortunately, to complete the initial load process. And then like they contacted us, and we recommended them to upgrade to Golden Gate for Big Data 21.8. And also we recommended them to use insert all records for the initial load process. And with the same initial load, like a replication configuration together with insert all records, and also with the same table of 75 gigabytes, they completed the initial load in around 1 hour. So like from around 6 hours into 1 hour. And that's the kind of like improvement, performance improvement we are talking about here. On the other hand, we also did a lot of improvements on the UI side, especially in OCI Golden Gate for Big Data. We added auto configurations for different targets. We also added serializer converter selections for streaming platforms. And also, you can easily create your connections and use them in your replication processes with OCI Golden Gate for Big Data much more easily. And again, with the recent changes, it is much easier to start your replication process with OCI Golden Gate for Big Data. And as I just mentioned, Julian is going to demo Snowflake replication after my session, and you can see the details within his session. Another point that I want to touch is the Golden Gate for Big Data's unique architecture for data warehouse targets called stage and merge. So we introduced stage and merge architecture design. I think it was like more or less like 2 years ago for one of the targets. It was for AWS Redshift and Autonomous Database like 2 years ago. And now actually it supports all the data warehouse targets supported by Golden Gate for Big Data. So today you can use this stage and merge architecture for OCI Autonomous Data Warehouse, for Snowflake, for Azure Synapse, for GCP BigQuery, and for Amazon Redshift. So in summary, Golden Gate for Big Data stage and merge replication is made of several steps, and these steps are executed by Golden Gate for Big Data replicate process. So as a first step, stage and merge aggregates the operations in memory. And at this step, Golden Gate for Big Data aggregates multiple operations on the same row into a single output operation based on a time threshold. And after the aggregation, a file rollover is triggered, producing local auto files. And then these files are loaded into related cloud storage services. So for example, if you're running Snowflake on Azure, and if you're using Golden Gate for Big Data stage and merge replication, these files will be temporarily staged in Azure Data Lake storage containers. And after that, external tables will be created on top of these auto files, and merge SQL or copy SQL, depending on the target data warehouse technology that you are using, will be applied to the target tables. So this flow, by the way, it is using external staging, is valid for all Golden Gate for Big Data targets supported, all the Golden Gate for Big Data data warehouse targets supported today. But on the other hand, Snowflake also supports a second stage and merge design using internal staging. And again, Julian is going to demo Snowflake replication, and in his demo, he is going to use internal staging. And by the way, just like one last note about this stage and merge design, all the steps, again, are handled by Golden Gate for Big Data. So let's assume that you want to replicate into, I don't know, Azure Synapse with Golden Gate for Big Data. In that case, you only need to configure a single replication for Azure Synapse, and all these steps that I mentioned are going to be carried out by Golden Gate for Big Data. So stage and merge design is actually advantageous for data warehouse targets. So by using micro batches, stage and merge scales up the performance, especially for update and delete operations. As insert operations are much more efficient, you can turn off the stage and merge functionality during the initial load phase by using the insert all records parameter that I was mentioning in the previous slide. Okay, so I also would like to remind about Golden Gate for Big Data microservices architecture. So last year, we went through the details of the microservices architecture with Golden Gate for Big Data. And Alex also shared a lot of details. And microservices architecture is available for Golden Gate for Big Data as well. So at core, it is the same Golden Gate for Big Data, meaning you can use the same configurations and properties with the same source and targets supported. In summary, there are 4 different services that manages extracts and replicates, and also trail file exchanges between different Golden Gate deployments. You can manage these services from the service manager. If you're running your source and target deployments in the same server, you can use a single service manager to manage them. And admin service is where you configure your extracts and replicates. Distribution service is where you configure your distribution paths or receiver paths for exchanging trail files between different deployments. And again, I left a link to a YouTube recording from our Golden Gate YouTube channel. And in that link, if you're interested, you can get more details about the microservices architecture design. And just like Volker demonstrated previously, we also support Golden Gate for Big Data with the migration utility. So you can use the migration utility for migrating into Golden Gate for Big Data microservices architecture from classic Golden Gate for Big Data classic architecture. Okay, so what's next? Looking forward, we are working on adding new source and targets to Golden Gate for Big Data. So we are working on adding GCP PubSub, Databricks, Couchbase as target, and Snowflake as source in the future. And we will also keep working on UI improvements, and we will make Golden Gate for Big Data easier to use and easier to configure. We are also working on a project for target table instantiation, which would auto-create the target tables in the replication process. So we have many different types of resources available today that you can benefit from. You can refer to Live Labs for direct hands-on experience with Golden Gate for Big Data, or you can check our YouTube channel for demo recordings, and you can also refer to Oracle blogs for much more technical details about the solution. So thanks for joining this session, and thanks for joining us today. And please contact if you want to have a technical deep dive session about Golden Gate for Big Data.